Hello everybody, and today we're going to graph rational functions. So the first thing I would do is find the vertical asymptote. So step one is check if the function is factored. So when I look at this one, I don't have to worry about that too much because this is just a linear function. So we can't take an x out. We can technically take a 2 out, but nothing is going to cross out and nothing is going to get simplified. So I'm just going to leave it the way that it is. And now I'm going to go on to my vertical. And for my vertical, it says to find the x values that make the denominator 0. So on the bottom, I just have an x. I'm going to set that equal to 0. So that means I have a vertical asymptote at 0. All right. Next, we're going to do horizontal. And for horizontal, we got to look at the degree. This is a 1, and this is a 1. So the numerator is equal to the denominator. Thus, divide leading coefficient. So y equals 2 divided by 1, because the leading coefficient is a number in front, which is 2 and 1. So you get 2. So at 2, we get a horizontal asymptote. So next step is we're going to go for our x-intercept. For my x-intercept, I'm going to take the numerator and set that equal to 0. And you will get negative 4, comma 0, which is right there. And then for my y-intercept, I must plug in 0 for every x. And this is undefined, so no y-intercept. So next, I need to just plug in random values to see where the graph is going. So I'm going to start focusing on this side, my left side real quick. Okay. And so on my left side, I'm going to plug in negative 2. And when I do this work, you got to be really careful not to make a mistake. I am guilty of it also, but we're going to get it together. So negative 2 is on my graph, which is right over here. I could have guessed that the graph was going this direction, but I just really wanted to make sure that everything lined up the way that I expected. And look at that. We have a nice graph on my left side. And now for the right side, you do the same thing. You're going to pick some values and see where it goes. So I'm going to go ahead and pick x equals 2. And we're going to get 6. This is going to be 2, comma 6. So once again, I can pick one more value, but I'm just going to show you most likely what I would do at this point is I would just go like this, because there's nowhere else for the graph really to go. But if we want to be sure, 8 plus 8, 16 divided by 2 is 8. So at 4, what did I get? Well, you see what I mean? Sometimes you go too fast and you got to go back, because what I didn't do was 2 times 4 plus 8. I didn't divide it by 4. So 8 plus 8 divided by 4 is 16 divided by 4, which is 4. So at 4, it's 4. And look at that. Even with my rough little sketch, I was able to get it. And this is how we graph it. So what do we still need to do? We still need to find our domain in our range. So let's look at our domain, which means all possible x values We're going to read it left to right. So I'm going on this journey on my X. At every single X point, my graph will touch the graph at some Y value, right? Like if I was like at -10, it touches right here. If I was -100, it touches right here. Like for every single X value, it touches it until we run into a problem, which happens right here. Do we see that when X is 0, which is where the vertical asymptote is, our graph does not touch this? Or when X is 0, you will never get a Y value. So what we're going to do is we're going to say our domain is from -infinity to 0, because 0 is where we run into a problem. And then from 0 to the rest of my X values, which if we continue to go this way, do you see that we touch our graph at some point? So that's why we can say from 0 to infinity. Some people are asking me what this is. This is a union. I kind of think about it as it's from here to here or from here to here. It's kind of like a punctuation or something that's showing transitioning from this section to this section. So that's how you do the domain. And I know that looks a little confusing because that looks like where the range is. But next we're going to do our range, which is all possible Y values, bottom to top. So as I'm looking at my Y, good, 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 good. Do we see that if we touch it at some point until we get to 2? So at 2 is the first time that our graph doesn't have a Y value of 2. So our range is going to be from -infinity to 2 to infinity. So to summarize that in a more concise way, our vertical asymptote, we need to exclude that from our domain. Our horizontal asymptote, we need to exclude that from our range, which explains the 0 and the 2. So let's do another one and see how we feel about that. So when I do this next one, the first thing I need to do is I need to factor. When I factor, I notice something. I know that to find my vertical, I need to take my denominator and set them both equal to 0. But this is interesting right here, because I'm going to do x plus 2 equals 0, and that's going to give me -2. That is one of my vertical asymptotes. But when I look at x plus 1, I have to reconsider what I'm going to do with it, because it divides out. So this x plus 1 equals 0 is actually going to be the x coordinate of something called a hole. And how I describe a hole is -1 would have been a vertical asymptote, but we cured it. And we cured it by being able to get rid of it. And by getting rid of it, I mean dividing it out. And so we divide it out. We no longer have a vertical asymptote, but we have a hole. And you can think about that as a scar or kind of like an indicator of something that used to be. And so a -1 is where our hole is now. And we're going to take this -1 and we're going to plug it into our new function. And our new function is just x plus 4 over x plus 2, because we were able to cross this part out. So I'm going to take -1, plug it in, and you get 3. And this is what we call a hole. And so at -1, I'm going to put a hole at 3. So that shows that there would have been a vertical asymptote, but now we don't. We just have a hole. And let me go ahead and make my vertical asymptote at -2. Now for my horizontal, this a 2, this a 2. So I know to take the leading coefficients and divide them, and we have a vertical asymptote at 1. And then we have this. So next, I need to find my x-intercept. And once again, I want to look at my new equation, which is so nice and clean, which is right over here. So for my x-intercept, I'm going to take my numerator, set it equal to 0, get -4, and now we got -4, 0, which is right here. Y-intercept, substitute 0 for x, and you're going to get 0, 2. So based on this, I can already tell that this graph looks like this, and this graph looks like this. But if you're not sure, I could always take, for instance, -6, plug it in, and you see how I get a +1/2. And you know, it's pretty much close to a +1/2. So it's -6, 1/2. I see that it's decreasing. So now let's do our favorite part, which is our domain and range, and probably one of the more confusing parts. So for our domain and range, we're going to start from the left at -∞, and we're going to ask ourselves, when does something strange happen with our x values? Everything is good until I get to -2, because at -2, that's where you have a vertical asymptote. And then from there, you're going to go from -2 to your hole. And your hole happens right here, which is -1. So you must exclude -1 also from your domain, which is why I'm putting a -1 here. And then you're going to go from -1 to infinity. So I'm going to go backtrack. I want you to look at the answer, but let's see why this happened again. So -2 happened because this is your vertical asymptote. -1 happened because this is your hole, or your x coordinate of the hole. So those are the reasons why you're excluding that. So let's go ahead and do the range. So for doing the range, you want to exclude two things. You want to exclude horizontal and y coordinate of the hole. Horizontal happens at y equals 1. Y coordinate of the hole equals, what was this point again, everybody? This was -1, 3, right? So that happens at 3. So our range is going to be from -∞ to 1, 1 to 3, and then 3 to infinity. And that's how you do that. Thank you.